Thank you for joining this lesson. We're going to study mathematics. This is a standard paper which is having questions across all the forms, and we're going to revise it right from number 1. Remember to subscribe to this channel and to also share the link with your friends. So number 1 is a question from Trigonometry 1. The question says, given that tan theta equals to 4 out of 3 and theta is an acute angle, find without using tables the cosine of 90 minus theta for 3 marks. So how to handle this question? I usually encourage students to first of all sketch. You just come up with a simple right-angled triangle whereby you're going to assume one of the acute angle is our theta. So the theta we are dealing with, having this one right angled, the theta will be at this point. Then automatically, the value of the angle at the top here, the value of this angle is 90 minus theta degrees. Now we've been told that the tangent of theta is 4 out of 3. We know that the tan of an angle is usually given by the opposite length divided by the adjacent length. So this is to mean now that the tan of theta equals to 4 out of 3, then with our angle here, it means the opposite length, which is here, is 4, and the adjacent length is going to be 3. That means we can again find the value of the hypotenuse, whereby we'll need 4 squared plus 3 squared. Then we obtain the square root. This is going to be 16 plus 9, which is 25. The square root of 25 is 5 units. Therefore, we're going to have 5 at this point. And with the 3 sides, any trigonometric ratio can now be found. And for this case, we are requested to find the cosine of 90 minus theta. So with 90 minus theta at this point, now we need the cosine. Remember, cosine is usually given by the adjacent length divided by the hypotenuse length. So we will need the adjacent length to that angle, which is 4, divided by the hypotenuse, which is 5 units. So now we are done with question number 1. Let us look at the question number 2. A rectangular room has length 12.0 meters and width 8.0 meters. Find the percentage error in estimating its perimeter. So the first thing to obtain here is the limits within which the dimensions have been recorded. For instance, we have the length, which is 12.0. It's good to know that when we get to this topic, 12.0 is different from exactly 12. So for us to know the limits of this length, then we need to add and subtract what we call the absolute error in the recording of the dimension. The dimension is to 1 decimal place. So which means we have to take 0.1 and we divide by 2. This gives us 0.05. This one is the absolute error in the recording of both dimensions because they are both to 1 decimal place. So we're going to add and subtract 0.05. When we subtract, you realize that the length is lying between 11.95 all the way to 12.05 meters, of course. The other thing now is the limits of the width. So we also add and subtract the same absolute error, bearing in mind that they have been recorded to the same accuracy. So this is going to be 7.95, the upper limit being 8.05. So those are the limits of the recordings for these two dimensions. The other thing now is to get the maximum perimeter. So let me get generally we say that perimeter equals to 2 multiplied by length plus width because it's just all the way around. So length appears twice for rectangular room. The width also appears twice. So we're going to talk about maximum perimeter, which will be given by 2 multiplied by the maximum length, 12.05, plus the maximum width, 8.05. And this is going to give us exactly 40.2 meters, of course. We're also going to talk about the minimum perimeter, which will be given by 2 multiplied by the minimum length, 11.95. Then we add 7.95, the minimum width, and this is going to give us exactly 39.8 meters. And we're also going to calculate actual perimeter. Now, actual perimeter is the perimeter given by the dimensions as they have been recorded, that is 12.0 and 8.0, and this is going to exactly give us 40 meters. So now we have all the perimeters. The next thing to do now is to calculate the absolute error in the calculation of the perimeter. For us to get absolute error, when the operation is an addition or a subtraction, we usually say that absolute error is given by either the maximum minus actual or the actual minus the minimum. Or we can take the maximum minus the minimum, then we divide by 2. So allow me go by the last option, which is 40.2 minus 39.8. Then we divide this by 2. So 0.04 divided by 2, and this will give us 0.2. That is the absolute error. And finally, we calculate now the percentage error. So the percentage error is given by relative error multiplied by 100%. So relative error on the other side will be given by the absolute error divided by the actual perimeter. Then now this one is what we shall multiply by 100. And this is exactly going to give us 0.5%. So that is all about number 2. We can look at the question number 3, whereby we are told that we find a quadratic equation whose roots are 2.5 plus the root of 3 and 2.5 minus the root of 3, expressing it in the form ax plus bx plus c equals to 0, where a, b, and c are integers. It's good to know that when the root of an equation have been provided for us to get the equation which is quadratic in nature, then we use the factorization method and in the reverse way, such that we will say before a conclusion was made that x equals 2.5 plus the root of 3. This means then the previous step was x minus, we now take them to both sides, x minus, this is 2.5, and again we subtract root 3. This all equals to 0. That is the first step. The next step will be again x equals to 2.5 minus the root of 3, which means that x minus 2.5, then now plus the root of 3. This is again equivalent to 0. So we had those two factors before the conclusion for the roots. This means now, before we got these two factors, it means immediately after factorizing the quadratic equation, then we must have had the two factors now multiplied then equated to 0. Remember, there are friends from other schools. You can share this link with them so that we may continue learning together. And now, before this factorization, or before this factorized roots, there was the expanded format of the same. And so we're going to expand this. So for us to expand this, we need to start by x times everything in the second bracket. So we need x multiplied by x minus 2.5 plus the root of 3. Yeah. Then again, negative 2.5 also multiplies everything. Then finally, the root of 3, which also multiplies everything. Then now we can say this is equal to 0. That is equal to 0. So I'm going now to open the brackets, whereby I have x squared minus 2.5x plus the root of 3x, then minus 2.5x. This becomes positive 6.25. Then finally at this point we're going to have a negative again, 2.5 root 3. Then we begin with negative 3, negative the root of 3x, then positive 2.5 root 3, and finally we shall have, this is negative the root of 9, which is negative 3. This is equal to 0. Then now we can group like terms together, whereby we shall just start with x squared because it's only 1. Then now we have a 2.5 and 2.5, both negative, and that will give us a negative 5, of course 0.0 now. Then there is a root 3x and root 3x at this point, which means root 3x and root 3x at this point will cancel out one another because they bear opposite signs. We have minus 2.5x and positive, that is minus 2.5x, and the other one here, they have already been grouped together. This one should be x. So now we go to minus 2.5 root 3 and positive 2.5 root 3, whereby they have to cancel one another. And finally, we shall have 6.25 minus 3, which means this will be plus 3.25, then equals to 0. So now, because we've been told that a, b, and c are integers, then we have to do away with the decimal. This is 3 1/4, remember? So 3 1/4 means 13 out of 4. Therefore, we're going to multiply the equation through by 4, which means we shall land at 4x squared minus 20x, then positive 13. And this is equivalent to 0. So we have the equation that we wanted. We have a number 4, which is a question on logarithms. Find the value of x that satisfies the equation log of x plus 5 equals to the log of 4 minus the log of x plus 2. Therefore, we shall start by, let me begin by introducing base 10 in this logarithm. Then I will be at the same time applying a law of logarithm, which says that the logarithm of a given number to the same base is usually 1. Therefore, the log of 4 to base 4 will be 1, and this means when we introduce the log of 4 to base 4 at this point, we shall not have affected the value of the term at that point. So I will start by the log, then I'll be talking about the log to base 10. This is the log to base 10 of x plus 5 equals to the log to base 10 of 4, then minus the log to base 10 of x plus 2. We can now apply a law of logarithm, which says when there is a minus between two logarithms, the log of a minus the log of b, as long as they are at the same base, then we can just take the log and a is divided by b. So applying this, we will talk about the logarithm to base 10 of x plus 5. This is equal to the log to base 10 of 4 divided by x plus 2. Then at this point now, we can drop the logarithms and equate the right hand side and the left hand side. So x plus 5 equals to 4 divided by x plus 2. We can multiply by x plus 2 both sides, such that x plus 2 multiplies x plus 5, and this is equal to 4. Then we expand and have x squared. Yeah, that's x by x. We get x squared plus, this is 5x, then 2x, which makes it 7x. Then plus 10. This is equal to 4. This means we can now group like terms together and have our quadratic equation. Then we solve it for values of x. So we will be talking about x squared plus 7x plus 6 equivalent to 0. With this, we can talk about a product of the value at this point, that is a times c, which is 6, and the sum of b, which is the value at this point, is going to be 7. Therefore, the two factors which when multiplied they give 6, and when added they give 7, are 6 and 1. So now we can replace 7 with 6 and 1, and this means x squared plus 6x plus x plus 6 equals to 0. So in the first two terms, we factor out whatever is common, and that is x. We remain with x plus 6. Then in the second pair of terms, we factor out just 1, and we remain with x plus 6. This is equal to 0. So x plus 6, x plus 6, then again in brackets, x plus 1. This is equal to 0. So we can simplify this by saying x plus 6 equals to 0, and also x plus 1 equals to 0. So x plus 6 being 0 means x is equal to negative 6. Then x plus 1 being equal to 0 means again x equals to negative 1. So those are the two values of x which satisfy the equation which has been given. Number 5, this is on chords and tangents together with circles and angle properties. In the figure below, ABCD is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral whereby the four vertices of the quadrilateral touches the circumference of the circle, as you can see, A, B, C, D. And BD is a diagonal. So BD is a diagonal to the given quadrilateral. EADF is a straight line. EADF, that's a straight line. Then we are told that angle CDF is 72, just as indicated, and BDC. So BDC is 45, again as indicated, and there is another given angle, BAE 80. This is 88. Let's proceed now. Calculate the size of ABD, that is angle, and CBD. Okay, for us to get these angles, allow me first of all just fill a few angles even before we go specifically to the angles that are needed. We start with the angle at this point. The angle BAD. The angle BAD, now that is a straight line, we just need 180 and we subtract 88. And this gives us exactly 92. If we have 92 at this point and ABCD is a cyclic quadrilateral, we can obtain the value of this angle because 92 and the angle at this point are opposite angles in a cyclic quadrilateral. And as we know, such angles should give us 180. So this is automatically 88. Now that we have that angle, remember we could still have said that the interior opposite angle of a cyclic quadrilateral is usually equal to the opposite or to the exterior angle. So exterior angle here should be equal to the interior opposite. So we could have concluded our 88 using other means. We can also say that we have a straight line DFA whereby there is 72 and 45. So we need 180 and we subtract 72 and 45. This is going to give us exactly 63. So the value of the angle at this point is 63. Yeah, that is 63. Then again, now with 63, again there is 92. The remaining angle here can be found. We just need 180 and we subtract 63 and 92. That angle is going to be exactly 25. So the value of that angle will be 25. There is another angle at this point whereby we just need 180 because there is a triangle there and the triangle is having 88 and another angle equivalent to 45. And this is going to be exactly 47. Therefore, now going back to the questions, we find that the sizes of the angles that we were to calculate are ABD. So ABD is going to be 25 degrees. Then there is also CBD. So CBD, the value is just as calculated, 47 degrees. Number 6, given that matrix A equals to 2, 4, 3, 6 and B equals to 11, 3, 4, 1, find C such that when we take matrix B times C, we should get matrix A. That is what we're going to exactly find. So we can have matrix B 11, 3, 4, 1. That is the first matrix. The other matrix is C, which is unknown. So we can give it elements, say A, B, C, D, for example. Those are just elements. When we multiply this, we're supposed to get matrix A. 2, 4, 3, 6. Then now we go to the multiplication of matrices now. When we take the first row here times the first column here, we're supposed to get the first element in the answer matrix. So 11 by A, 11A plus 3C, we're supposed to get 2. That is one equation. Another equation can still be formed when we say, when we take the row here and we multiply again with the first column, we should get the element at this position. So 4 by A plus, this is 1 by C, so C equals to 3. That is the second equation. Now this pair can be solved because it's having A and C. So allow me to say that from the second equation, this is second equation, this is the first equation. So from the second equation, the value of C is 3 minus 4A. C minus 4A. So I'll be re-expressing the first equation now, whereby I will talk about 11A. Then I add 3 instead of C. I rewrite it now with 3 minus 4A. Then this is going to be 11A plus 9 minus 12A equivalent to 2. Then we group like terms together. This is minus A, which can be made positive to the right hand side. Then when we talk about 9 minus 2, this will be 7. Now with the value of A, we can directly get the value of C, whereby we need to substitute C equals to 3 minus 4 into the value of A, which is 7. So this is going to be 3 minus 28, which is negative 25. Negative 25. So now with A and C, we can proceed to get the other two elements which are yet to be found, so that we can express our matrix. So now I'll be going again back to the matrix, and we talk about the first row times the second column here. Now we will get the element at this point, that is according to the multiplication of matrices. So 11B plus 3D, we're supposed to get 4. And again, when I take this row times the same column, I should get 6. So I'll be talking about 4B plus 1 by D, which is D. I am supposed to get 6. Allow me solve using the same method, which is the substitution method. This is the fourth, this one is the third equation. So from the fourth, D equals to 6 minus 4B. And with this, we can rewrite the third equation, 11B plus 3 instead of D, 6 minus 4B. This is equivalent to 4. So 11B plus 18, then minus 12B, this is equivalent to 4. Then we group like terms together. This is 11B minus 12B, so we can have B to the right hand side. Then we'll be talking about 18 minus 4, which is 14. So the value of B is 14. And with the value of B, now the value of D can be obtained. We need to take 6 minus 4 into 14. This is going to be negative 56. So 6 minus 56 will give us negative 50. So we have A, B, C, D, which means the matrix C can now be expressed as A, B, C, D. So A, the value of A is 7. The value of B is 14. The value of C, negative 25. And finally, the value of D as negative 50. So now we have the matrix expressed. The next question. Remember, you're supposed to share this link with friends. That will encourage your peers to also learn something during this holiday. We have number 7, which is talking about intersection of chords. The chords A, B, and PQ intersects internally at O. So this is at point O. Given that the length of A or OP equals to 8, OA equals to 4.5, and OQ equals to 6, calculate the length of OB. When chords intersect internally in a circle, we usually say that up to the point of intersection, we are having, for example, length BO. or OB anyway. When we multiply it with OA, this will be the same as when we take PO, then we also multiply with OQ. So now with these values, we can substitute. The length BO is unknown, but the length OA is known to be 4.5. So when we multiply it with the unknown BO, we should obtain the value of PO, which is 8, multiplied by OQ, which is 6. So we should remain with OB or BO as a length when we take 8 by 6 and we divide by 4.5. And this is going to give us exactly 10.6 recurring. So we can talk about a 10.67 centimeters to 4 significant figures accuracy. Number 8, make U the subject of the formula. X equals to U squared V divided by U squared plus 2W. So for us to remain with U at one side, exactly that is what we call making the subject of a formula. We have to change the subject of this formula, whereby we need to remain with we can multiply through by U squared plus 2W. We also do the same for this other side. So we shall have X multiplying that. We will have U squared X plus 2WX. This is equivalent to U squared V. Remember, this one will cancel at this point. So now we can group the terms with letter U together such that we remain with 2WX. Then we have U squared V minus U squared X. Yeah. Then now we can factor out U squared to remain with V minus X. This is 2WX. So to remain with U squared, we can divide through by its coefficient so that we have 2WX divided by V minus X. Then now that we have a V squared, yet what we want is, we have U squared, but what we want is letter U. Then to remain with U, we have to take square root both sides. So the square root is either plus or minus the square root of this other value, which is 2WX divided by V minus X. So that is the subject of the formula now in terms of U. Again, we have a number 9. Simplify 1 plus the root of 3 into 1 minus the root of 3 and hence evaluate 1 divided by 1 plus the root of 3 to 3 significant figures, given that the root of 3 is equal to 1.73 to 1. When you look at the values here, 1 plus the root of 3, then we are also having 1 minus the root of 3. This is what we call a difference of two squares. According to the factorization, these terms are just the same, but in the first factor, they have a plus. In the second, they are having a minus. So a simpler way of dealing with a difference of two squares is to first of all expand it. And when this one is expanded, it will become this value squared, which is 1, then minus the second term also squared. So we have 1 squared, then the square root of 3 squared, which becomes 3, and the simplified will be negative 2. So we have already worked on this part now. Simplify. That one has been simplified. And actually, whenever you are dealing with surds, it's good for students to know that a surd and its conjugates are just a factorization of a perfect square. They're just a factorization of a difference of two squares, that is. So a factorization of a difference of two squares can be expanded very simple in such a way, and hence evaluate. So now we need 1 divided by, here we are supposed to take 1 plus root 2, which means we have to take 1 plus root 2, root 3 as an equivalence of 1.73221. Yeah, but before substituting it, let us talk about the root of 3 itself. Just a minute, sorry. This is going to be 1 divided by, let me just rewrite it here. 1 out of 1 plus the root of 3. Remember now the question is a surd, so we are supposed to talk about the conjugate, 1 minus the root of 3. Then we also multiply with the same, the root of 3 on the numerator. So we'll have 1 minus the root of 3, that is on the numerator, divided by, when this one is expanded, we have already seen that the answer is -2. That means we need to take now 1 minus the root of 3 has been provided, 1.73221. Then we divide by -2. This is going to give us a -0.7321 out of -2. So the negative cancels and we shall have 0.366. Remember, it should be to 3 significant figures. So that is it. Number 10, on sequences and series. The sum of the second and the 14th terms of an arithmetic progression is 15, and the sum of the 5th and the 6th terms is 25. I guess for the same progression. Find the first term and the common difference. So we're going to solve now a question here on what we are calling arithmetic progressions. For us to get nth term for a given arithmetic progression, nth term is usually given by the first term plus n minus 1, then this multiplied by d, which means for us to get the second term, we just need a, then we add 2 minus d, which is just d. That is the second term. Now we are saying that the second term plus the 14th term. So again a plus 14 minus 1, 13d. This one is giving us 15. So that is the first equation. Then we continue reading to extract the second equation. We are told that and the sum of the 5th term. So the 5th term is going to be a plus 5 minus 1, which is 4 multiplied by d, 5th term, and the 6th term. 6th term is going to be a plus 6 minus 1, that is giving us a 5 multiplied by d. This is equal to 25. So now we can simplify these equations and solve them. This is going to be 2a, then plus 14d. This is equivalent to 15, the first equation. The second one is going to be 2a plus, this is a 9d, equivalent to 25. This is the second equation. Now we can solve simultaneously, and because already the coefficients of a are the same, we can eliminate directly. So 2a minus 2a, that becomes a 0. 14d minus 9d, that becomes a 5d. This is equal to 15 minus 25, -10, and the value of d is going to be exactly -2. With the value of d, we can now substitute in any of the equations and we get the value of d. Assuming we substitute in equation 1, or substituting in equation 1, that is, we will have 2a plus 14 into d. This is equal to 15. So to remain with 2a, now we have to talk about, this is -28. And remember, on the other side, there is 15. So when we take 15 plus 28, we're getting a 43. And the value of a will exactly be 21. 21.5. So we have the first term, A, as 21.5, and the common difference of the progression as -2. So the two unknowns have been found. Number 11, 12 men take 20 days to complete a piece of work. How long would 16 men take to do the same piece of work? We're going to have now men here. Then we talk about the days for work. 20 days. Okay, 12 men. Let's begin with 12 men taking 20 days. Then now we want how long would 16 men. So 16 men, assuming that they are such men and working at the same rate, how long are they going to take? So we're going to have the number of days now determined. So we start with the number of days, which is 20. Now we're going to increase or decrease days with the ratio of men. If 12 men are taking 20, 16 men are expected to take a shorter duration, which means we shall decrease 20 in the ratio of men. That means 12 should be there and 16 should divide. And this is going to give us exactly 15 days. So 15 days is the answer. We're going to have number 12 now. Number 12, let us talk about, without using tables or calculators, evaluate the sine of 60 degrees, the cosine of 60 degrees, divided by the tan of 30, sine of 45, leaving your answer in surd form. So for us to solve such a question, we have to know how to express these special angles in surd forms. And I will simply take an equilateral triangle of 2 units such that we have 2 units, 2 units, and also 2 units. Then the angles, of course, are each 60. And if each is 60, when I divide through there, I'll get 1 unit here. But now the angle here will have become 30, and the one here will have remained 60. The length here can be evaluated by taking 2 squared minus 1 squared. This is 4 minus 1, that is 3. So the square root of 3. So the square root of 3 will be the length here. If that is the length there, then we can say the ratios for 60 and 30 can be obtained. For example, we need sine 60. So the sine of 60 is going to be opposite out of hypotenuse. So sine 60 is going to be root 3 divided by 2 multiplied by the cosine of 60. Cos 60 is going to be adjacent out of hypotenuse. So 1 out of 2. Then this is divided by the tan of 30. 30 is at this point. So the tan is usually opposite of hypotenuse, or opposite out of adjacent length. Sorry. So with 30 at this point, we need 1 out of root 3. So 1 divided by root 3. Now this one is going to be multiplied by the sine of 45. Let us go to 45. For us to work with 45, now we have to get an isosceles triangle. Isosceles triangle which is also right-angled, such that it's right-angled here, but isosceles with 1 unit, 1 unit. So for such an isosceles triangle, then the hypotenuse is going to be 1 squared plus 1 squared. That is 1 plus 1, the square root of 2. Now with this, we can, remember this is 45, since we have a 90 here. So now the sine of 45, sine is given by opposite length out of the hypotenuse. So 1 divided by the root of 2. Yeah, 1 out of the root of 2. So now this is the first substitution. Now we go to the solution of this. In the first case, we have root 3 divided by 4. That is on the numerator. Then we're going to divide by 1 out of root 6. This is 1 over root 6. So dividing by 1 over root 6 means times root 6 over 1. Yeah. So we're going to have the root of 18 out of 4. And now we cannot leave a surd unless it is simplified. So we're going to talk about root 18 being equivalent to, this is 9 times 2, then out of 4 here. So the root of 9 is known to be 3, but the root of 2 is irrational. So we shall remain with the final answer as 3 root 2 divided by 4. And finally now at number 13, the figure below shows the graphs of y equals to 2x plus 3 and y equals to negative 2x squared plus 3x plus 4. Remember, they are intersecting at Q. So the first question is determine the coordinates of Q. This is going to be, because it's a point of intersection, then the two equations are going to be solved simultaneously. And for us to solve simultaneously, we can even use what we call the substitution method, whereby y has been expressed already. So in the second equation where there is y, we put 2x. So the second equation here can be written as, instead of y, we have 2x plus 3. This is equal to negative 2x squared plus 3x plus 4. Then now we can group like terms together. We can even start with 2x at this point. Then we have 2x minus 3x, which becomes negative x. Then this is 3 minus 4, making it negative 1 equals to 0. So now we can solve this by taking a product of negative 2, that is a 2 by negative 1, and a sum of negative 1. The two factors, which when multiplied they give us negative 2, and when added they give us negative 1, are going to be negative 2 and 1. So that now we go into the determination of the exact value of x. So now we're going to say that 2x squared, instead of minus 1, we can have minus 2x, then plus x. Then we have minus 1. I'm just writing this one, minus 1 equals to 0. So we will talk about the first two terms. We factorize x, okay, 2x, to remain with x minus 1. Then we factorize 1 to remain with x minus 1 equals to 0. So x minus 1 equals to 0. And also 2x plus 1 equals to 0. So with this we can talk about x minus 1 equals to 0. So x equals to 1, or 2x minus 1 equals to 0. So 2x equals to negative 1. And the value of x will be negative 0.5. Negative 0.5. So for the value of q to be relevant, the coordinate at q, it's on the positive side. So the x that we choose is 1. So with 1 as x, now we can get the value of y by substituting it in this equation, and y will be exactly 5. So the coordinates of q are going to be 1, 5. 1, 5, and we enclose. So we are talking about the point here to be 1, and this one, the height here to be 5, because the value of y is 5. Yeah, so that is the coordinates of q. Find the exact area of the shaded region. Let us study the shaded region. You will discover that the region is bounded by the curve. It's also bounded by the straight line, y equals to 2x plus 3. It's also bounded by the line vertical axis. That is the shaded area. So we can first of all get the area between the curve and the x-axis, and again the area between the straight line and the x-axis up to the limit of this line from the y-axis. Therefore, for us to get area below the curve, up to the x-axis, we need to first of all integrate from 0 to x equals to 1 the curve negative 2x squared plus 3x plus 4 with respect to x. Then now we subtract the area bounded by the line, the x-axis, line x equals to 1 and line x equals to 0. But instead of integrating this line, we can also see that from this point, remember we have the equation of this line, which means it cuts the y-axis at 3. So we have 3 units here, we have 5 units here, and from 0 to 1, there is 1 unit. So we have 1, 3, 3, which means we can take the unshaded area as a trapezium. The shape is a trapezium, and we shall have minus half into 3 and 5, then multiplied by 1, the length between the two parallel sides. So this is going to be 8 divided by 2, which is 4. So we are subtracting 4. Then now we're going to integrate this. This is going to be negative 2/3 x power 3 plus 3 out of 2 x squared plus 4. We introduce x now, then a constant, the arbitrary constant of integration from 0 to 1. So when we substitute 0, everything will become 0. But when we subtract 1, we're going to get 4 and 5 out of 6, then minus 4. This means that the shaded region is going to have area equal to 5 out of 6 square units. So let's wind up with the paper. We're now going to number 14. Number 14, we are told a solid cylinder of radius 6 centimeters and height 12 centimeters is melted and cast into a spherical balls, or a spherical balls, of radius 3 centimeters. Find the number of balls. For us to get the number of balls, we need to get the number of balls. We have to know the volume of the cylindrical solid. Then we divide by the volume of the spherical ball obtained. Volume of the sphere, so that we know, because we are taking a cylindrical solid to make spherical balls, we can get the number of such balls by dividing the two volumes. Volume of a cylinder is usually given by the cross-section area, which is circular, multiplied by height. So pi r squared multiplied by h, divided by the volume of a sphere. Remember, the cylinder has a bigger radius, but now for the sphere, we need 4 out of 3 pi r cubed. Pi r cubed. So now we can see pi is featuring on both sides. So we just need r squared, that is a 6 times a 6 multiplied by height of 12, divided by 4 over 3 r 3 times 3 times 3, because it has to be cubed. This is exactly going to give us, a 12 balls, or we can work out even slowly. So we're going to have by 4 1, by 4 3, by 3 1, by 3 1. This is 36 over 3. We're going to get 12 balls from that. Number 15. Two similar canes have different heights, 8, and the other one 10 centimeters. The surface area of the larger cane is 480 square centimeters. Find the surface area of the smaller cane. Okay, with the two heights, which are dimensions measured in linear scale, we're going to say that they can help us get linear scale factor. they are linear dimensions. They are just to one dimension. So 8 out of 10 is giving us linear scale factor. This is going to be 64 out of 100. Now with linear scale factor squared, yeah, to give us 64 out of 100, this will exactly be the area scale factor. If when the heights are related, they will give us 8 over 10, then the surface areas or any other area for the given cans should give us, when the same ratio is squared, that is a 64 over 100, which means with 64 over 100 and surface area of the larger is known, then surface area of the smaller can automatically be found, and it's going to be, this is going to be, because we want for the smaller, we take 480 and we decrease it in this ratio, so 64 over 100. This is automatically going to be 307.2 square centimeters. And finally, find the value of x which satisfies the equation 16 power 2x equals to 8 power 4x minus 4. So we're going to put the numbers or the composite numbers into a common base, that is a base 2. So 2 raised to 4, there is already an existing power. 8 is equals to 2 power 3, and there is already an existing power. Then now we can have 8x equals to 2. This is 12x minus 12. Now that the base is common, or the base is the same, we can equate the powers. That is 8x equals to 12x minus 12. We can have 12 to the left hand side where it becomes positive, then 12x minus 8 giving us 4x, and the value of x will automatically be equal to 3. So that is the solution to the equation above. Thank you so much for following. Subscribe and share.